All right, let's dive in. Today, we're looking at a master roadmap for becoming a true robotics expert. And I mean, this isn't just about theory. This is a 3-year blueprint that shows you exactly how you go from nothing to a complex modern robot. Let's get into it. So, here's the big question, right? How do you actually build a modern robot from the ground up? I mean, with autonomous cars and crazy automation everywhere, what's the real process that turns an idea into an intelligent machine? It's a huge undertaking, and you can't just wing it. You see, the answer isn't just learning some code or how to solder a few wires. Building a really sophisticated robot, that requires a structured, industry-proven process. It's a whole methodology that guarantees quality, safety, and efficiency, right from the very first idea to the final product. And this is it. This is the heart of the whole thing, the V model. You've got to think of this as the master blueprint for the entire journey. It guides you from the initial concept way over on the left, down through the design phase, and then all the way back up the right side through super rigorous testing, and finally building the physical thing. This is the exact framework the big players in automotive and robotics use. Okay, so let's see how this V model actually works in the real world, starting with year one. The whole focus here is on forging the digital blueprint. And the main idea is this. Before you even think about ordering a single physical part, the entire robot has to exist and work perfectly in the digital world first. Now, to build that digital twin, you're going to need a pretty powerful toolkit. So in the first year, you're mastering the absolute fundamentals. The math that makes things move, advanced programming in C++ for speed and Python for quick ideas, and of course using GitHub to keep all that complex code organized. You also get deep into the physics of robots and learn how to design its body using 3D CAD software. And all that learning comes together in a really tangible project. By the end of the first year, you've actually built a complete virtual prototype. You've got a 3D model of your robot and a working app, a human-machine interface that can actually see its sensor data. The robot is still just software at this point, but it's totally ready for the next phase. Which brings us to year two, and this is where things get really intelligent. This is the phase where we awaken the robot's virtual brain. All the logic, the AI, the control systems, it's all developed and, this is so important, it's all tested like crazy in a simulation. This is really where the magic happens. You learn to give the robot eyes with computer vision, you craft its brain with AI, and you use what are called real-time operating systems to make sure it can react instantly when it counts. And critically, you learn to use ROS2, which is basically the industry standard operating system for robots, to connect all these different pieces together. So the most important point is this. By testing the robot's software over and over again in a simulated world, you can find and fix bugs for cheap and, more importantly, safely. I mean, you can crash a virtual robot 1,000 times and it costs you nothing. This whole simulation-first idea is the core of the modern V model, and it prevents so many disasters and saves companies millions of dollars. The final project for year two proves this whole concept. You take your AI and control logic, you move it into ROS2 modules, and you verify that the entire software brain works perfectly in a super realistic physics simulator called Gazebo. At this point, the robot's brain is fully built and fully tested. Now, what's so interesting here is how this whole testing process is broken down. See, the V model isn't just one giant test. It's a sequence of 4 different testing loops that take you from a pure idea all the way to real hardware. And we've actually already seen the first 2. The very first stage is called Model in the Loop, or MIL. This is as pure as testing gets. You're not even testing code yet, just the math and the logic behind your whole system. You can think of it like checking your equations on a virtual whiteboard to make sure your basic idea even makes sense. Then you move on to Software in the Loop, or SIL, which is what we saw in that year 2 project. Here, you take the actual C++ or Python code, the stuff that's going to run on the robot, and you test it inside the simulation. That flight simulator analogy is just perfect. You're testing the real software in a virtual world to make sure it behaves exactly like you think it should. Which brings us to the most exciting part, year 3. It is finally time to give this robot a physical form. All that verified work from the digital world is now carefully brought over and integrated into real, actual hardware. The skills you learn in this final year are all about bridging that gap to the real world. You're running the final 2 stages of the V model testing. You're mastering functional safety to make sure the robot doesn't do anything dangerous, and you're tackling the very complex job of putting together physical sensors and motors. This is the moment software finally meets steel. So the next testing stage is processor in the loop, or PIL. Now we take that code that we've already tested in simulation and we load it onto the actual microcontroller, the robot's physical brain, for the very first time. The goal here is to see if the code runs correctly and if it's fast enough on the real chip. It really is the code's final dress rehearsal. And finally, we get to hardware in the loop, or HIL. This is the ultimate test before you let the robot loose. You connect the robot's final computer, running the final code, to a powerful simulator that feeds it incredibly realistic sensor data. You're basically testing the brain's final reactions to a simulated world one last time. And the grand finale of this whole 3-year journey? A fully assembled, autonomous physical robot. But it's so much more than just a working machine. It comes with a complete documentation package that follows industry standards like ASPICE. That's a quality framework that big auto companies demand to make sure software is safe and reliable. This is exactly what top employers want to see.
So after 3 years of intense work following this master roadmap, what's the ultimate reward? Well, it's not just a diploma. It's something far more valuable out in the real world. You see, the outcome isn't just one final robot. It's a portfolio built on 6, count them, 6 major engineering projects. And each one proves you've mastered a critical part of the modern development process from start to finish.
This table just sums up the journey beautifully, doesn't it? Year 1 delivers the digital design. Year 2 delivers the verified virtual intelligence. And Year 3 delivers the fully integrated physical robot. It's just a logical, powerful way to build up a massive set of skills. And this right here is the whole point. Graduates don't just leave with knowledge, they leave with proof. They have a real, tangible portfolio that demonstrates to any high-tech employer in the world that they don't just know the theory, they've actually done it. They've successfully built a modern, safe, and complex robot. And that leaves us with one last big question to think about. In a world that demands proven skills, not just credentials, is this type of hands-on, validation-first education, where you literally build a professional portfolio as you learn, is that the future for all complex technical fields? It's definitely something to chew on.